everyone. This problem is a quadratic application, very similar to the one on the homework that you're working on right now. And this can be found in the handouts that you printed out from last class. Okay, there's a handout with 2 quadratic applications, and this is one of them. So this is a very common word problem to do with quadratics. When you throw an object or shoot an object up into the air, and you chart how high it is for the time that it's in the air. This is called projectile motion. So this function represents the height in feet of a BB shot from a BB gun as a function of time in seconds. So we're going to do a couple things with this today. We are going to first figure out what is the max height of this BB. How high is it going to reach? And when does it reach that height? So that right there is going to be the first thing, and then we'll do part 2 after that. Okay, so when we see any quadratic that we're trying to find a max or a min, immediately we should be thinking about the vertex. Okay, so as soon as I see this being asked for max height, then I know I'm looking for a vertex. Okay, because for a quadratic, the max and min always occurs at that spot. So this is really a fancy way of asking you to find the vertex. So we have to figure out what form this is in. We go back to our function up here, and we see that it's in our general form, right? It's in that ax squared plus bx plus c form. So we know from last class that in order to find the vertex in that form, we have to do our little formula. We can't use our transformations. We have to use our x sub v equals opposite of b over 2a. In this case, maybe I'll rewrite that. Let me be completely correct with my variables, and I'll write it as t sub v because my input in this case is time. So this is going to look like this, right? Opposite of b is going to be negative 136 over 2 times negative 16. So when I do that out, I'll have negative 136 over negative 32. So in this particular case, because of this application, our vertex should have a positive input value. We know from quadratics we've done in class that that's not always the case, but when we're talking about time and height, if we were looking at this, just a real rough sketch of it, we can see that this has an initial height of 5, right? And it's coming up and back down. That would be the path of or that would be how high it is when I chart the height versus time. And so we know that this max value should happen when time is positive. So this should come out to be 4.25 when we do that. So that really gives us this right here. Right? It gives us how long it takes. That's what we find first, how long it takes for this BB to reach its max height. So to find what the actual max height is, I just have to finish the vertex, right? I have to really find my output. So I have to find h of my 4.25. Let's see what's happening to this BB once 4.25 seconds goes by. So we're going to take and we're going to plug that in everywhere we see a t. And we're going to come out with, okay, so you guys do this along with me. Sorry, I'm getting a little bit messy here. My stylus is not the easiest thing to write with. Okay, so if you do that calculation, you should come out to a 294. So I'm going to put units on these. So this would be feet, and this up here would have been seconds. So really, let's write out what this is saying. We're saying the max height of the BB is 294 feet after being in the air for 4.25 seconds. So that is my vertex. So that means that up here would be at 294. So the next part that we're going to find, the next important thing you're going to see me drawing green here is, well, we figured out how high it went. We know its initial height. The next thing would be to find how long does it take for it to reach the ground again. So that's going to be the next slide that I have here. Okay, so part 2, how long does it take for the BB to reach the ground? So now for it to reach the ground, and this, you're going to see how this relates also. The last one we did relates to the vertex, which we've been spending some time in class finding. And once we figure out if reaching the ground means that my h of t is 0, and you'll see this directly relates to what we were doing last class when we were solving all those quadratics. So we've got various methods to now solve that. We're going to find the two values for t. We'll see if they both make sense, but we will get two values for t where h is 0, where the height is 0. And so we've got to look at that, and we have to decide the best way to solve it. Okay, so most of the times when we're doing an actual application like this, we're going to default to the quadratic formula. If we try to do completing the square, we would have to divide out -16 there because we have to have a leading coefficient of 1, and that does not go in evenly to everything, so it's probably not the best method. So we've got one side to be 0. Let's pick out our A, our B, and our C. So we've got -16, 136, and 5. So what I would do if to use this video to practice this is I would stop the video right now, and I would try to plug these all in and see what you get, and then join me and see if we get the same thing. Okay, so I'm going to start plugging in. So my t equals opposite of b plus or minus, okay, b squared minus 4 times a times c all over 2 times a. All right, so I have some simplifying to do here. Now, if you got things that were not real here, if you found yourself using I on this problem, something had to have gone wrong, because for these, they should be real answers, right? We know it's going to hit the ground at a real value. So let's see, we get this 136 squared is 18,496. And then underneath, so that ends up being a plus when we do -4 times -16 times 5, we get plus 320. So we can see actually already that this is going to come out to be a positive value underneath the radical. So under the radical, we end up with 18,816. Just working through the quadratic formula. Just try to make a little bit more room here. Okay. And let's see. So we get, so I'm going to have to round this. That's not a perfect square. So I'm going to get -136 plus or minus. So this is not a square root, a radical that I would expect you to put in lowest radical form with a huge number like that. We are going to want to figure out what this actual time is in terms of a decimal. This makes sense to put this as a decimal. So we're just going to go onto our calculator and round that. Let's round it to the nearest hundredth, which comes out to be 137.17, all over -32. So I have two, I'll call them T1 and T2. Okay, so if I do T1, I'm going to do -136 minus 137.17. I'm going to get a value. And then the other one would be -136 plus 137.17. Okay, so if we do these two values out, let's see what we get. So sometimes in a problem like this, they both make sense, and sometimes only one makes sense. So let's see what we have. So if you do the one T1, that one comes out to be about an 8.54. And if you do T2, you get about a -0.04. All right, so the reason why one of these is negative is because if you remember, I'll just draw a little sketch over here again. This started out as it had initial height already, so it went up and back down. So the other the first x-intercept is giving it like what would happen if it had, you know, if we were talking about negative time. So since this had initial height of 5, it's saying it really would have reached the ground before that. So this is not valid. It's not applicable for this scenario. And so what this one says is, okay, after it takes off, it takes 8.54 seconds to reach the ground again. So that's the one we're looking for in this one, the 8.54 seconds. Okay, so that was a good example of using the quadratic formula for an application. So hopefully this helps you with your homework this weekend, and then we will do one more of these in class on Tuesday.